Hi, welcome to my video on the equation of a normal line number 5. And again, another example of finding the equation of a normal using different functions. Here we go. Find the equation of a normal line to y equals sine theta cos theta at theta is 2 pi over 3. 2 pi over 3. Well, first of all, let's take 2 pi over 3, and I like to equate it, instead of in radians, I like to look at that in degrees. So 3 and 180 is 60. 2 times 60, so we have a 120 degree angle. 120 degree angle. So let's draw a circle and plot a 120 degree angle. So here's the circle. 120, 0 is here, 90, so 120 is roughly rotating from here to here. So we draw a terminal arm out, perpendicular to the x-axis. So that's 120. That means the reference angle, which is right here, is 60. So this is the 30. Now I could use a unit circle, but I'm going to use the normal triangle, where we have the hypotenuse is 2, opposite 30 is 1, opposite 60 is root 3. And because this is in the second quadrant, the x is negative, the y is positive, and the hypotenuse is always positive. So now let's work out at where theta is 120 degrees. So y equals the sine of 120 and the cosine of 120. Sine is opposite over hypotenuse, so that's root 3 over 2. Cos is adjacent over hypotenuse, which is negative 1 over 2, so that gives us negative root 3 over 4. So the point that this occurs at on this graph is, we can say, let's go back to radians, 2 pi over 3 and negative root 3 over 4. Now let's look at the slope of the tangent. So, because the normal line is perpendicular to the tangent, so the slope of the tangent, let's see, let's look at the slope of the tangent, but we have theta here. So let's look at the slope of the theta as dy d theta, because we got to do the derivative in terms of theta. So that means y equals sine theta cos theta. So let's do d theta on the y, and we'll do d theta on sine theta cos theta. So this becomes dy d theta. Let's make that theta there. And this is an f and a g, so f prime g plus f g prime. So we'll do the sine of theta derivative times cosine plus sine theta times derivative of cos. So this is derivative of f times g and f times the derivative of g. So that gives us derivative of sine is cos theta, and we got sine theta. Derivative of cos is negative sine, and we simplify that. We have cos squared theta minus sine squared theta. Now, because the angle is in the 120, that means the cos of 120, the cos, we found it to be here to be 1/2 with a squared, and the sine, which we worked out to here, is root 3 over 2. We're going to square it. So that gives us 1/2 squared is 1 over 4 minus root 3 squared is 3. 2 squared is 4. So that gives us negative 2 over 4, which is negative 1/2. So the slope of the tangent, is negative 1/2. So that means the slope of the normal at the same point is the negative reciprocal. So that's a negative, we make it positive. Reciprocal of 1/2 is 2. So the slope of the normal is 2, and it's occurring at the point 2 pi over 3 and a negative root 3, 4. So that's the x and the y. That's the slope. So y equals mx plus b. So we got the slope. We got to get the b, the y-intercept. So y is negative root 3 over 4. The slope is 2. X is 2 pi over 3 plus b. So it's negative root 3 over 4. And that's 4 pi over 3 plus b. So that means that b is negative root 3 over 4 minus 4 pi over 3. So the equation of the normal, we have the slope is 2, b is negative root 3 over 4 minus 4 pi over 3. So the slope is 2, so it's 2 times x, and b is negative root 3 over 4 minus 4 pi over 3. So that's the equation of the normal. Again, I wanted to do in terms of trig and theta, so I did dd theta instead of ddx, because these are not x's, but dx, ddx, and dd theta, you still do the derivative the same. So that brings us to the end of this video, and like all the others, again, if you like my video, click the like button. If you're not a subscriber, you can subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.